how we doing? We are going to learn a little bit about what we call interval notation and inequality. So I don't know if you've seen inequalities or not for a little bit, but check it out. So we've got to talk about what an inequality is, how it's written, stuff like that. So like inequality means things that aren't equal. So like straight up, it'd be like we say make a statement like x is less than 3. That means all numbers that are less than 3. So it means like negative 11 billion, negative 10, 2.999999999999999999999999999999999999999999999999999999999999999999999999999999999. No, I didn't freeze the video, didn't get frozen. But 2.999999 works as well. That means everything up to 3, everything a little bit less than 3 is a viable solution to that. Which is different than if I do this, x is less than or equal to 3. That means that everything all the way up to 3, including 3, with that underline is the equal to part. That means 3 works too as a solution. Here's another one, 5 greater than x. That means 5 is greater than all of the numbers that are viable, which would mean 5.1, 5.000000001 would work, 5.5, 11 billion would work, 1 billion would work, those types of things. By the way, 11 billion is not a number, it's just a number I made up because it sounds fun to say. True story. Okay, so here we go. So there are symbols and graphs related to each one of these numbers, and it's been a little bit since you've seen it. So like, for example, less than is that symbol, right? Less than or equal to that symbol, greater than that symbol, greater than or equal to that symbol. The graph associated with that would be, it's going to be an open circle, whatever the number is, and it would be to the left. Not because it's pointing, or let's delete that. I'm not going to show you the graph. We'll talk about the graphs in a little bit. Typically, if it's x less than 5, we would go 5, open circle, meaning you can't get to 5, you just get close to it. If we get that x is less than 5 or equal to 5, we would turn around and we would have the number 5 here, and we would have a filled in circle and shaded to the left. Greater than, x is greater than 5 would be this. We would have an open circle here at 5 and to the right. X is greater than or equal to 5, we would have an open circle or a closed circle. The inequalities up at the top, we've got the graphs that represent those inequalities, and we have something called interval notation. Now, a thing to note is that there are special symbols that are related towards the type of sign. So these two and these two, when we're talking about interval notation. In particular, if we don't have the equal to part, we're going to use a parenthesis to represent it. And if we have the equal to part, we're going to represent using a bracket. Either one of those two things. Now, again, if it does not have the equal sign, we're going to represent it using one of the parentheses. Okay, and if it does have the equal sign, we're going to represent it with a bracket. Okay, keep that in mind. There's 2 other symbols that we need to talk about. We need to talk about what's called infinity and beyond. No, that's Buzz Lightyear. So just infinity. We need to talk about infinity. We have something called negative infinity, and we have something called infinity. Meaning, infinity means it goes on greater and greater and greater, gets larger and larger and larger without bound. Just keeps going. Doesn't stop. Just keeps going. Negative infinity means it goes negative, 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 more and more and more and more and more negative. So like it goes from -1 to -2 to -3 to -4 to -5 and keeps going that way. It's just a concept that represents keeps going more negative. Positive infinity or infinity means it's a concept that just keeps increasing and it doesn't stop increasing. So stick those up in your noggin and keep them there, and we're going to reflect on those in a bit. So when we talk about inequalities, so like if we have the inequality x is greater than 3, that could be represented by what we call the interval parenthesis 3 infinity parenthesis. What that means is this statement says we're going to have the number 3 and we're going to go up without bound. It's going to keep going, everything greater than all the solutions work out for that. That's what this interval says. This interval says we want the number 3 as a bounding value, and we want to take it greater than all the way to infinity, and that just keeps going. We have to also notice that it's parentheses here because in the inequality itself, it doesn't have the equal sign. And we never put a bracket on, a closed bracket on infinity because we can't ever reach it. So we never get to infinity, so we always put a parentheses. So when we look at the graph here, those two are represented by the same graph, meaning we go from 3 all the way up to infinity, but we never get to 3. So we have a parenthesis because it's an open circle, and we always go to the, super far to the right, and we're not stopping, which means we're going to go to infinity. That's the way the arrow is pointing. Okay? Okay. Rewind that if you need to rewind that so you understand what I actually said rather than just jotting down those notes. Okay? So let's look at that. Closed infinity. So if we have the statement x is less than -2, that means we're going from -2 and we're going all the way to the left. Or when we talk about it in numerical order, we're going to go from -infinity, furthest to left, the arrow is going to keep going, and then we're going to stop at -2. Okay, and we're actually going to reach -2. So right here, when we talk about this, we have our bounding region, -2. So we would like write that number down, and then we know that all the solutions are less than that. So we want to represent that by a value or a concept that is less than -2. So since it's less than -2, we want to write it to the left of, because that's the way we write them in numerical order. And then we decide what kind of symbols we need around those. We always put a parenthesis around infinities, okay? And the question is, on that critical point, that bounding value, we want to decide, is it going to be a bracket or a parenthesis? In this case, we have the equal sign, so we have the bracket instead, okay? Now, when we go over here and we compare that to the graph, again, we had it's going to the left forever, so that represents -infinity. That means going to the left forever. And we stop at -2. So we have a bounding value of -2, but we also have that as a closed bracket, right? Because it's filled in, and we never put a closed bracket on infinity. Again, numerical order. Here we go. Here's some examples. When we talk about interval notation, so I actually prefer to go to the graph first and then back to the interval because I like visualizing it that way. So if I go here and I go 5, okay, that's a critical value, and we want x to be less than 5. So we want everything to the left of that on the number line. So we're going to shade here. And we want an open circle to represent we can't get to 5. The open circle represents we don't actually get there. All the shaded in stuff represents we can get to that value, but the open circle stuff represents we can't actually get there. Now, when we turn around and go to an interval, on the graph, we can look at it. It's going to the left forever. That means it's shaded super far to the left, means -infinity. And we go all the way up to 5, but we don't include 5. So we're just going to leave a 5. And we don't include 5 since it's the open circle. So we're going to use a parenthesis. Next one. Okay, we're going to go to the graph first. 0, 8. It's an underline, so we're going to do a closed circle. And it's not pointing to the left, but we mean x. We want the solutions to be less than or equal to 8. So we're going to the left. It's not that it's not that the arrow is pointing to the left, because this inequality would have the same exact graph, okay, even though it's flip-flopped. If you want to, by convention, always put the variable on the left, you can do that to make sure you're safe, but you have to understand what those symbols mean. Saying it out loud helps, stuff like that. Now I'm going to turn around and go to the interval. Notice how the graph goes all